Alrighty, we're going to use this Google slide presentation, which is what you guys will have access to, and so you guys can go through this. But you should be taking notes over this, and a little different, not using the Jamboard. I don't need to write a lot on here, but if you look, we're looking at types of chemical reactions, and so there's going to be 5 of these, and that's pretty easy for you guys to remember, just 5. And I'm going to show you basically clues or patterns that you can look for. And so now we're going to be doing the balancing, but we're also going to say, okay, this reaction is a certain type. And the cool thing is, if you know the type, then you can start to predict, that's what it says down here, predict the products. So we can start to predict the products. So what are the, like if I give 2 chemicals, what are they going to make? So if I give you the reactants, what are the products going to be? And that's sort of that upper level skill, and we'll look at that at the end. And we're going to keep it pretty simple. You can't predict everything. There's some weird patterns, but we're gonna use this to try and give us an idea. So, all right. So let's take a look here. All right. Parts of a chemical reaction. You guys should know this. We've got reactants. They're on the left side of the arrow. So right, we're writing down the reaction, and we've got the right and the left side. So the reactants on the left side, or you can think of them as the starting chemicals. So what are we putting together? What are we mixing? And what's going to happen is the products. The products are what happens. So these are your ingredients, your starting items, left side of your arrow. And then your products are what you end up making, right side of the arrow. So when you're doing these, you're looking for clues. And a lot of the clues are going to say things like you have 1 reactant, you have 1 product. Your reactants are an element and a product, etc. So those are the clues that you really want to focus in on when we're trying to figure these out, because the clues are how you're going to get them all right. So, all right, here's kind of an overview. These are the 5 types that we're going to look at. Now there are, I guess if you are in a different class, take this in college, you're taking this at University of Kansas, University of Missouri, taking this at Harvard, wherever you're at. There are some different variations, but for us, these 5 are going to work fine. The variation is usually right here on number 4. So sometimes your instructor might call this a neutralization or an acid-base reaction, and that's just going to be a slight variation on this. Same concept, just a little bit more specific. So these are the 5 we're going to look at. So we got the combination or the synthesis, so just putting things together. So like I'm taking 2 chemicals and I'm putting them together. So I want you to look at the graphic here. Over here, you can see that they're separate, and then over here they're combined. So this is just they're combined. Opposite here are combined, and then we're busting them apart. Single replacement, so you got an individual item and then a group. So we call that an element and a molecule, or an element and a compound more likely. And then here we go, an element and a compound over here. So it's a new element. So what happened is this guy, this A, came over and booted that out. So we'll look at that a little bit more. Double replacement is 2 big items or 2 compounds, making 2 compounds. And then combustion, we're going to get a very specific reaction every time. We have a fuel, and then we have some pieces. Now, you don't need to write these down here. We're going to see them on other slides. I guess you can pause and write them down if you want. It's a very good graphic, but we're going to look at them all individually. Slide over. Here we go. All right. Okay. Synthesis or combination. So 2 words for the same thing. So you could write down synthesis, you could write down combination, you could write down combo. Once again, if you're at a different, you're at a different high school, you're at a college, your instructor could require synthesis or combination. They're the same thing, but basically if you have two chemicals, A and B, then they make one chemical. See it's stuck together here, it's bonded. Then that's going to be combination or synthesis. So right here's the clue. Put a star by this when you're setting up your clues. One product, one thing on the right side of your arrow. That's the clue, and you want to be good with that clue. So here we go. This is individual, right? AL's by itself, CL's by itself. So there's a plus sign, right? There's two things over here, and then they went together to make one thing. So this is the key. Don't look over here as much as, hey, there's only one item. And when I mean one item, AlCl3 is it's a single compound. There are two of them. I mean that there's one type of chemical over here. The AlCl3 is the only chemical, so a single product. The coefficient could be a 2, a 3, or a 4, but the chemical itself, there's only one product. There's more than one mole of them, but there is only one chemical you're writing down over here. So you might want to say one product, and underneath it say a chemical. There's only a single chemical, not things split up. No plus signs, basically. All right, decomposition is the opposite. You start with the chemical, and it breaks apart into pieces, so we have one reactant. So once again, I have a 2 here for the balancing, but when I say one reactant, I mean there is only one type of chemical on the left side. So this is the opposite of your combination, opposite of your synthesis. And so you have the reverse. And so if you just reverse this and we went this direction, if we went towards the left side, then we have combinations. So they're just backwards. So that's the clue, one reactant. And so you want to make sure you have that clue. So decomposition, you're looking for one thing over here. The only chemical equations that have a single item over here, they're always going to be decomposition. You could have 2 over here, you could have 3 over here, you could have 4 over here, but as long as you have one piece over here, you're going to say the decomp. And you can abbreviate these when you're doing your problems and stuff. Don't have to write out the whole decomposition. Okay, single replacement. So look at this. If you look at the graphic, the A came over here and it booted the B out. So see, the A is now where the B was, and the B is by itself. So what happens here is you're looking for one element and one compound, and then on the other side, the right side, a new element and a new compound. So we're making some new stuff. So the orange here is the clue. Look for one element and one compound on both sides of the arrow. So here we go. Na is our element, and then FeCl2 is our compound. Now look what happened. Now the Na is where the Fe was. They switched or replaced each other. Fe is alone. And now we have the new compound, salt, NaCl, and the new element. Now, when you're doing these, this Na, if it's a plus, which Na is a +1, it's going to replace the front because the iron is a plus. If it was a negative, like say this was an iodine, a -1, it would replace the back. So it's very common to replace the fronts, but you do need to be careful because if this is a negative, like if it's a O, an oxygen would be -2, it replaces the back. You're never going to have two pluses together, so NaFe is never going to work. All right, and there. So I'll look at this more specifically when I do predicting the products, but just look for the element, you know what those are, and a compound on both sides, and you should be fine on this one. So once again, I'll go over the predicting products on another video. So it's not like you're going to have to do that right away. Okay, double replacement. These are the biggest types of chemical reactions. You have two compounds on both sides. So see, these are compounds. They're elements stuck together. And they made new compounds. And so if you look, same thing I was talking about on the other side. See, the fronts or the pluses are switching. So see, Ag switches with Na. That's because they're the pluses. So the pluses switch places. You would not want Ag and Na together. They're two positively charged ions. They're like magnets. They're going to repel each other, so they're not going to go together. And so we want a plus with a minus. And so look for two compounds on both sides of the arrow. So here it is, just kind of rewritten as a formula. So the AgNO3, and now the Ag is with the Cl. So the picture and then the formula down there, it's the same thing. So here's the clue in orange. Just look for compounds on both sides of the arrow. So I'm looking for lots of chemicals, right? See, lots of chemicals. It's probably going to be double replacement. And again, you can abbreviate these, right? You don't have to write out the whole thing. We do a lot of DRs and SRs and things like that. So, all right. So then the last one, combustion, kind of the weird one. It has the fuel, which is the hydrocarbon. So this is our fuel down here. That's actually propane on this particular example, C3H8. So there's your fuel. And what happens is your fuel combines with oxygen, and then it creates carbon dioxide and water. So if you're driving a car that's not an electric vehicle, it has an internal combustion engine. And in the engine, you put in a fuel, right? Like you put a fuel in your car in the gas tank. And what happens is that fuel, the fuel vapors go in and they combine with oxygen. You have an O2 sensor in your car, and then a spark from your spark plug that creates combustion, and then that creates a gas. Well, actually, carbon dioxide and water. So it creates a couple of gases, and these gases are what push the pistons. So the pistons are like if you have a 4-cylinder car, you have 4 cylinders, and the fuel is combusting, and then it creates a gas, and that gas moves the piston, and that creates that mechanical energy, which actually turns the crankshaft and drives your car. And that combustion reaction happens over and over and over. And if you have like a bad O2 sensor, your car will not combust correctly. And so then it will not run well. And so your car basically runs off of this principle. But all combustion is going to be based on this principle. So the only thing that changes in a combustion reaction is the fuel. So see, this is a CH, and then this is a C3H8. But see, these pieces are the same. You always combine with oxygen, and you make CO2 and water every single time. So here's the clue. Look for carbon dioxide and water as our products. All right. Got a couple minutes left here. Here's sort of the overview. One product on the right, synthesis or combination. One reactant on the left, decomposition. An element and a compound on both sides. That's going to be single replacement. And then compounds on both sides. These are the big reactions, right? Like lots and lots of stuff. Double replacement. And then combustion. See, this piece right here can change, and it can be different combinations of C's and H's. So it could be like C4H10 or CH4. It can be all kinds of things. But these three are identical every time, outside of balancing, of course. And so you're looking for these products. And so this is how you identify them. So I'm going to pause the video here. And then when we come back, I'm going to just do a little, have you guys run through a little example problem, see if you guys can figure them out. So I'm going to pause it here.